This electrical setup is a significant safety concern and likely violates modern building codes. A single 20-amp fuse can only handle a maximum of 20 amps of electrical current. If multiple appliances or devices are used simultaneously, it could easily overload the fuse and cause a fire. Fuses are designed to protect individual circuits from overloads. However, in this case, the units are sharing a single fuse, which means that if one unit has an electrical fault, it could affect both units. The landlord is responsible for ensuring that the electrical system is safe and meets code requirements, and here, they have failed to provide adequate circuit protection. There are several options available. Firstly, contact the local building authority. They can inspect the electrical system and issue a notice of violation to the landlord, who must then address the issue within a specific time frame. Secondly, negotiate with the landlord to have the electrical system upgraded to meet code. This could involve installing a new fuse box or circuit breaker panel with individual circuits. Thirdly, if the landlord refuses to upgrade the electrical system, there may be grounds to terminate the lease due to unsafe conditions. It is recommended that the unit not be occupied until the electrical system has been upgraded. Have a qualified electrician inspect the electrical system. Consider contacting a lawyer if the landlord is unwilling to address the safety concerns. An electrical system relying on a single 20-amp fuse for an entire dwelling unit, especially in an older building, raises significant concerns regarding safety and code compliance. Let's break down the issues and potential remedies. Fundamental problem lies in the limited capacity of a 20-amp fuse. In modern electrical systems, circuits are designed to handle specific loads, and a single 20-amp circuit is often inadequate for the demands of a typical living space. Overloading this circuit is a major hazard. Electrical overloading occurs when the current flowing through a circuit exceeds its rated capacity. In this case, if the occupants use multiple appliances or devices simultaneously, such as a microwave, hairdryer, and lights, the total current draw could easily surpass 20 amps. When this happens, the fuse is designed to blow, interrupting the circuit and preventing a potential fire. However, relying solely on a single fuse for an entire unit is extremely risky. Frequent fuse blowing is not only inconvenient but also a sign that the electrical system is undersized and potentially dangerous. It's crucial to understand the concept of circuit protection. Modern electrical codes mandate that each circuit be protected by a fuse or circuit breaker of the appropriate size. This protection is intended to prevent overcurrents, which can cause overheating, insulation damage, and fires. In the described scenario, the lack of individual circuit protection means that a fault in one appliance or area of the unit could affect the entire electrical system. Moreover, it increases the risk of a fire spreading rapidly. Landlord responsibilities are a key point. Landlords have a legal and ethical obligation to provide safe and habitable living conditions for their tenants. This includes ensuring that the electrical system is properly installed, maintained, and meets current code requirements. Failing to provide adequate electrical service and protection constitutes a breach of this responsibility. Now let's consider the available options to rectify this situation. Contacting the local building authority is a crucial first step. Building authorities are responsible for enforcing electrical codes and regulations. An inspection by a qualified electrical inspector can identify code violations and provide the landlord with a formal notice to correct the deficiencies. This notice will typically specify necessary repairs or upgrades and set a deadline for completion. Negotiation with the landlord is another viable approach. It might be possible to persuade the landlord to upgrade the electrical system voluntarily. This could involve explaining the safety concerns and potential liability issues associated with the current setup. It's helpful to present the landlord with a clear plan for upgrading the system, including cost estimates from qualified electricians. Upgrading the electrical system typically involves installing a new electrical panel with multiple circuit breakers. Each circuit breaker protects a separate circuit, allowing for a more balanced distribution of electrical load and enhanced safety. The number of circuits required will depend on the size and layout of the unit, as well as the anticipated electrical demand. Terminating the lease is an option if the landlord is unwilling to address the safety concerns. Most lease agreements include clauses related to habitability and safety. If the landlord fails to provide a safe living environment, the tenant may have grounds to terminate the lease without penalty. However, it's important to consult with an attorney before taking this step to ensure compliance with local laws and lease provisions. Recommendations for moving forward should be taken seriously. Before moving into the unit, insist that the electrical system be upgraded to meet current code requirements. This will provide peace of mind and ensure a safe living environment. Engaging a qualified electrician is essential for assessing the existing electrical system and recommending appropriate upgrades. A licensed electrician can perform a load calculation to determine the required capacity of the new electrical panel and the number of circuits needed. Furthermore, legal counsel can provide guidance on tenant rights and options for addressing unsafe living conditions. A lawyer can review the lease agreement, advise on legal strategies, and represent the tenant in negotiations with the landlord or in legal proceedings if necessary. Here are additional considerations regarding the electrical system. The age of the wiring is a significant factor. In older buildings, the wiring may be outdated and unable to handle the demands of modern appliances. Old wiring can become brittle and cracked, increasing the risk of electrical shorts and fires. It's essential to have the wiring inspected and replaced if necessary. Grounding is another critical safety feature. A properly grounded electrical system provides a path for stray electrical current to flow safely to the ground, preventing electrical shocks. Older buildings may not have adequate grounding, which can pose a serious safety hazard. Ground fault circuit interrupters, or GFCIs, are designed to protect against electrical shocks. GFCIs are required in areas where water is present, such as bathrooms and kitchens. These devices monitor the flow of current and quickly shut off the power if a ground fault is detected. Arc fault circuit interrupters, or RFCIs, are designed to protect against electrical fires caused by arcing faults. Arcing faults occur when electrical current jumps between wires or components, creating heat that can ignite nearby materials. RFCIs are typically required in bedrooms and other living areas. It is important to understand electrical codes and standards. The electrical codes are sets of regulations that govern the safe installation and maintenance of electrical systems. These codes are developed by organizations such as the National Electrical Code, or NEC, and are adopted by state and local jurisdictions. Compliance with electrical codes is essential for ensuring the safety of occupants and preventing electrical hazards. Common electrical code violations to be aware of are overloaded circuits, which occur when the current flowing through a circuit exceeds its rated capacity, creating a risk of overheating and fire. Another is improper wiring, which includes using the wrong size or type of wire for a particular application, making loose connections, or failing to properly insulate wires. Ungrounded outlets that lack a grounding connection can pose a shock hazard. Damaged or exposed wiring is a safety hazard, especially if the insulation is cracked or frayed. Tampering with electrical equipment, such as bypassing safety devices or making unauthorized modifications, can create dangerous conditions. Inadequate surge protection can leave electronic devices vulnerable to damage from power surges caused by lightning or other electrical disturbances. Ignoring warning signs, such as flickering lights, burning smells, or frequent tripping of circuit breakers, can lead to more serious electrical problems. To resolve electrical problems, it is critical to identify the root cause of the problem before attempting any repairs. If you are not comfortable working with electricity, it is best to call a qualified electrician to diagnose and fix the problem. Ensure that all electrical work is performed in accordance with local electrical codes and regulations. Before starting any electrical work, always turn off the power to the affected circuit at the breaker panel. Use appropriate safety equipment, such as insulated tools, rubber gloves, and safety glasses. Never work on electrical equipment while standing in water or on a wet surface. If you are unsure about how to perform a particular electrical task, consult with a qualified electrician. Regularly inspect electrical cords and appliances for damage. Replace any damaged cords or appliances immediately. Avoid overloading electrical outlets or extension cords. Use surge protectors to protect electronic devices from power surges. Install smoke detectors and carbon monoxide detectors to provide early warning of fires and carbon monoxide leaks. Develop an emergency plan in case of an electrical fire or other electrical emergency. Teach children about electrical safety. By taking these precautions, you can help prevent electrical accidents and ensure the safety of yourself and others. Another consideration is the presence of aluminum wiring. Aluminum wiring was used in some homes built in the 1960s and 1970s. However, aluminum wiring is more prone to corrosion and overheating than copper wiring, and it can pose a fire hazard. If the unit has aluminum wiring, it should be inspected by a qualified electrician and replaced or properly remediated. It is important to look for signs of electrical problems. Flickering lights, outlets that don't work, and circuit breakers that trip frequently can all be signs of underlying electrical problems. These problems should be investigated and repaired promptly to prevent more serious issues. Electrical safety tips are extremely important. Never overload electrical outlets or extension cords. Use appliances with the proper voltage and amperage ratings. Keep electrical cords away from water and heat. Never use damaged electrical cords. Have a qualified electrician inspect your electrical system regularly. Install smoke detectors and carbon monoxide detectors. Develop an emergency plan in case of an electrical fire. Here are some additional safety measures to consider. Regularly check the condition of extension cords. Replace any cords that are frayed, cracked, or otherwise damaged. Avoid running extension cords under rugs or furniture, as this can trap heat and create a fire hazard. When using power tools or appliances outdoors, use a ground fault circuit interrupter, or GFCI, to protect against electrical shock. Be careful when working near power lines. Maintain a safe distance from power lines and never touch them with any object. If you experience an electrical shock, seek medical attention immediately. Even a mild shock can be dangerous. Consider having a whole house surge protector installed. A whole house surge protector can protect all of your electrical devices from power surges caused by lightning or other electrical disturbances. Be aware of the signs of an electrical fire. The signs of an electrical fire include a burning smell, smoke, and flames. If you suspect an electrical fire, evacuate the building immediately and call the fire department. Here are some specific code references that may be relevant. NEC 210.21 Overcurrent Protection addresses the requirements for overcurrent protection of electrical circuits. NEC 210.24 Branch Circuit Requirements specifies the minimum requirements for branch circuits, including the number and type of outlets allowed on each circuit. NEC 250.4 General Requirements for Grounding outlines the requirements for grounding electrical systems to protect against electrical shock. NEC 310.15 Ampacity of conductors provides guidance on the ampacity or current carrying capacity of electrical conductors. NEC 406.4 Receptacle Rating and Type specifies the requirements for the rating and type of electrical receptacles. Here are some resources for learning more about electrical safety. The Electrical Safety Foundation International, or ESFI, is a non-profit organization that provides information and resources on electrical safety. The National Fire Protection Association, or NFPA, is a non-profit organization that develops codes and standards for fire prevention and electrical safety. The Occupational Safety and Health Administration, or OSHA, is a federal agency that sets and enforces standards for workplace safety, including electrical safety. Here are some additional points to keep in mind. The electrical system should be inspected by a qualified electrician before any renovations or remodeling are done. Any electrical work should be done by a licensed electrician. Permits may be required for certain types of electrical work. It is important to follow all local electrical codes and regulations. If you are not sure about something, ask a qualified electrician. Always err on the side of safety when it comes to electricity. Dealing with electrical issues requires a cautious and informed approach. Prioritize safety and seek professional assistance when necessary to ensure a safe and compliant living environment.